Good morning, everyone. We shall start our class. Yes, in the previous class, we have started discussing this interprocess communication. We know what is the use of this interprocess communication because all the task or any single task which cannot be performed by a single process. A single process, it will hand over its job to its child process, to its related process, and then the part of the work will be done by the other process. That is why there will be a communication between the process. Therefore, you have to support the communication path for these processes. That is why this is called as inter-process communication. There will be exchange of data between uh, multiple processes. This is one example of this, the figure of this inter-process communication. You can visualize like that. In order to support the inter-process communication, the mechanism that is given is pipes. The one mechanism is this pipes. There are two types of pipes. One is this normal pipes. What we know, we don't use the word normal. Pipes, just pipes, or the named pipes. The pipes are used for communication between the processes who are all relatives. Means the process which is communicate with its ancestors. Means the communication between the parent and the child, or who don't have a common parent. The child processes which have a common parent, those processes also they can communicate. Means a child between a child. Uh, uh, that is with this pipes, and named pipes is nothing but a communication between the different process, means unrelated process. Relation is not there. These pipes, what they are going to give mechanism is you can transfer the data. It works in the first in first out manner. It works in first in first out manner. They have just given the names pipe because there will be two ends. One end we are going to write the data, in the other end we are going to read it. That is why they have given the name called pipe. And and this pipe in the background in the operating system, if you check, it is just a memory. It is just a memory, and whatever the operations you do on that, it is a memory operations. There will be no inside the raw material like pipe from one end, the hardware, there will be a pipe from one end, you are going to send the data, from other end you are going to read. It is not like that, it is just a memory operations. There will be a file, from that file there will be a control on that file. You are going to do this as usual, the read operation and the write operations. You can visualize like this, and these ends, end this ends, right end and the read end, that we can be controlled, or you will going to get the address from the variable called the file descriptors. From these file descriptors, you are going to get the address of that, and then you are going to write the information to that, or you are going to read from that. For that, we are going to programmatically, if you see, it is, yesterday I have shown you one program, I think I have closed. Yes, this is one sample program. Yesterday we have shown you a parent process, what it is going to do, and what the child process will do. We are going to send the data from one end, read from the other end. How to create a pipe? To create a pipe, we have a inbuilt function called pipe. For that, what you have to pass is, you have to pass an array of two elements. One is FT0 and FT1, file descriptor 0, file descriptor 1. One is for write, another one is for read. And the values inside that array will be set by the pipe function. The value inside that, it will be set by this pipe function. It will store the value. And also I have shown you the numbers in the previous class, that is 6 and 7. When I have run that, it has stored 6 and 7. Those are the numbers. It is just one unique number. It is just a unique number. In the background, in the operating system, if you check, there will be a related address for that. And in that location, the value is getting stored. For us, they are not going to give the address, just they will give some other alternate number and an integer. And you can create a pipe. If it is less than, if it works properly, it will going to give 0, the meaning it is working properly, or else less than 0 means there is some error. There is some error. PID equals fork. PID equals fork. It is just you are going to create the child process. After that, parent process will execute this block. Child process will execute this block. What the parent process is doing is, there is some assumption that we have to first close the unused end. If you are writing, if you are doing some write operation means close the read end, and if you are doing the read operation means close the write end. That is why close of FD0 and then write to FD1. Close of FD1 and read from FD0, because the other process should not interfere. That's all. During these operations, the other process should not write anything by mistake or for some any other reasons. They should not do this. That is why we are going to do this operation. The next thing is, and here the hello world, it will print here because it is going to write to the standard output file. Standard output means to console it is going to write, and you can see the output there. From here the data is sent when the parent process is executing. When the child process is executing this block, it is going to print. And also we have seen the limitations of pipes, half duplex, and pipes can communicate only with the common ancestors. It means related process. Yes, the next topic that we have to start is P open and P close. See, this P open and the P close is what we used to do till now. We are going to create a pipe. After that, in the background, it is going to fork a child, means you have to create the child process. After that, close the unused end and execute the commands if you want to run, or the waiting for the waiting for the command to complete. All these things we used to do, right? Instead of this, all these things that will be done by a single function, this P open. P open, in the background, everything is going to do. The magic function, P open, you can use directly. Instead of pipes, you can use, instead of PIPE function, P open you can use. What is the use of this P open is, P open, in the argument, if you pass, I think it is visible, or else I'll show it in the textbook itself. This is the function. Say file P open. Say this is the function P open, FP open, and the arguments are the command string and the type. See, this is the function you have to use instead of pipe. From now, you are not going to use pipe. Now we will use P open. What it is going to do, all the things what we used to write till now, creating the pipe, forking a child, closing the unused hands, and if you want to execute the commands, everything. These two functions, P open and P close, is going to do this. Now, what we have to do is, any function that you are going to execute, that you have to pass it as an argument. See, in the previous example, what we did is, we are just write the hello world, and we have from the parent, and we have printed in the child. But it is not only that much use, even you are going to execute the commands, pass the output of the one command to the other command. That command, it is going to use it. In that case, that situation we are talking about, there you have to execute a command first. That is why in the P open, they have given the argument as command string. The pipes Most of the times pipes will be used for running the multiple commands in a single stretch, and the outputs of the one command is fed as an input to the other command. In that situation itself, they are going to use it. That is why p opens in the command arguments. You can see command string, and there will be another pointer called type. The command is for any command that you want to run. You can give it as the first parameter. The second parameter is R. The possible option for the type is R or W. Means you can open the pipe as a read end, or you can open the pipe as from the right end, for the write. See, in the previous case, we have done that FD0 and FD1. Now FD0, 1 is not there. Everything you have to mention with R and W with the second parameter type. If you give read as a type for this, in this place for type, if you have written R, then it is like this: p open command string comma in the double quotes. If you write R, what is the meaning of that is the file pointer that will be connected to the standard output, that will be connected to the standard output of the command string. The file pointer is connected to the standard output of the command string. 1 minute. Okay. See, this will be that the file pointer is connected to the standard output of the command string. What is the meaning of that is, see, whatever the command is going to be executed, we are going to read from the standard output of the command string, because the command string, it will execute the p open. What it is going to do is, in the background, it will do this fork and execute function. As I said, in the background, it is going to do the fork and the execute function to execute the command string, and it will return you the input output file pointer. It will return you the input output file pointer. What that file pointer contains, if you go to that location, you will get the output of that command string. You will get the output of the command string there, that is already been in the standard output. You can read from there. You can read the output from there itself. Means that the command, it is, what is the meaning of it is, this pipe, it is opened, it is as readable. You can read from that location. The file pointer means it is nothing but it points to some location. If you go there, you can read from the output of that command. That is the meaning of that. P open command string dot R. It will execute that command, and it will give the address of that standard output location, and you can read the output of that. If you have opened the open the pipes in the write mode, like this, p open of command string dot R, then the file pointer is connected to the standard input, which is connected to the standard input of the command string. If it is, the meaning is you can write to the standard input. That is the meaning of this. What about the p close is going to do is, the p close, it is going to close the p close, it is going to close the standard input streams itself. It is going to close the standard input output streams are there at standard input and standard output. Those streams, it is going to terminate, and also it will return the termination status of the shell. whether it is 0 or 1. In case if the command has not executed properly, then the termination status returned will be exit of 127. You have seen this 127 in the previous classes, right? Exit function, that 127 error that it is going to return. Two things, the P close it will do. The P close, it is going to close the standard input stream, input output stream, waiting for the command to terminate and return the termination status, whether it is 0 or 1, anything. But after the other one is, if it shell, it cannot execute that command itself because the command may be a problem, you have done any mistakes. In that case, it will give you the error of exit of 127. The next thing we are going to discuss in this is process. Which one? See, this is the way you are going to give the commands. P open ls star.c open in the read mode. Command 2 greater than &1 in the read mode. This is how we are going to open P open instead of pipes, because you have to write the lengthy program. Now you can write only a single function. Now you can write only a single line. Don't create a use the fork. Don't do, no need to create a pipe, if else, so many cases. One example is there with a pager example. A pager, it is one environment variable, that's all. It is one environment variable. Here what they are doing is, we are going to pass the command line arguments. We are going to pass the command line arguments. If it is command line arguments, if it is not equal to 2 means, then you have not sent anything. Or else, you are going, if you have sent the any file, it will try to open. If it is not possible, it will say that you cannot open that file. It says it cannot open that file. That is the second if. The third if is, it will try to open the pager. See, P open pager. Pager is some preprocessor directive. It is a preprocessor directive $pager. We are opening it in the write mode. What is the meaning of this is, this colon is, you will try to open this pager and it try to print it. Execute this command called pager. This is environment variable. What value it contains, it is going to print it. That's all. P open pager means when it executes that command. Pager is also a command. It will try to execute. If it is not possible to execute, then if it is not being defined, :-more indicates instead of this, choose this string, select this string more. That is the meaning of this. If the pager, if it is undefined, it is not defined and it is non-null, it is going to print. Otherwise, it uses the string more. That is the meaning of that. It uses the string more. See, the program looks big. One thing I have to say, whenever you read the textbook, when you see this example, in that the maximum will be error handling itself. See, this example, the most of the case, this first two if and the last two if, they are just the error handlings. The logic of this program, it is there in this, the third if and this while loop. Only it is present in that. The other ifs are, it is just the file handling. That is why whenever you learn the program also, more you should concentrate on this, the main logic, this P open, this F getters, F puts. All this error handling, F error, P close, this argument, F pin, you can add, or even if you miss, it is not a problem. That is why see where which part is the main logic and which is just a error handling, and first learn the logic itself and practice that. And the remaining thing, the error handlings, all these things, it is the next preference. The main thing you have to write in the exam or in the test, the main thing you have to write this part. Just writing the error handlings, if the arguments is not there, if it not tries to open that file, if you write only that much, It is not a complete program. But if you write just these things, this if and this else, the logic part, it may not work in the worst case, but in the best case, it is going to work. But if you write only just the error handlings, even it will not work in the worst case or in the best case. That is why please concentrate. Don't look the program. It is so big. Just concentrate in that where is the logic and first practice that itself. I think now it is clear what is P open and P close. There are so many other examples are there, P open and P close. And we cannot discuss all those examples. Very few will discuss, and then we'll go to the next topic called the co-processes. Before that, going to the co-processes, try to see one more example. Before going to the next topic is co-processes. After that, it is the FIFOs, users of FIFOs, and in the same way, client-server communications we will do. Yes, you can send your attendance. 39 people have joined and 42 attendances. So it is possible. I think multiple times you will send the attendance. I think you have a doubts on your software itself. I think everyone has sent the attendance. We'll discuss this co-process. See, before going to the co-process, try to understand this example. Here, there is one program which is called as a filter. There is a program which is called as a filter. We'll understand why this name filter here and what this program is doing. This program is just converting an uppercase character to the lowercase. This program, it is converting the uppercase character to the lowercase. See here, while loop, C equals get char, whatever the character I enter, if it is not the end of file, that character will be stored in C. See whether it is upper, it is condition is satisfied, it will change it to the lower. If that is if C, whatever the enter, it is /n, means the last line, everything I have completed, all the characters. If it is completed, then if I press enter the /n new line character, then it is going to write it to the standard output. It is going to write it to the standard output. That is the meaning of F flush. It is going to, you are going to flush everything into the standard output. Means you can, if you enter in the lower case, you can see the output in the uppercase. That is what this function is all about. We are going to execute this program and we are going to store with the name, the executable file name is my uppercase to lowercase. That is the name MYUCLC. This program, this function name is myUCLC uppercase, and that is the executable file name. Executable file name means whenever you compile the program, in the background, if you check you can go to that location where the .c file is stored. There, all the intermediate files are stored: .c, .bak, .obj, and .exe file. There you can see that file. That is the name I am saying, the executable file name. Executable file name is the file extension of that is .exe. The execution file name is .exe. Now this program is compiled and the executable file that we have stored my uclc.exe. Now this file we are going to invoke from the next program. See, this is the next program we have created. This program here, p open, see my uclc. This is an executable file. Now we are going to run this program. P open, it is going to run this program in the read mode. If it is not possible to run, it will give you null value. In that case, p open error. If it is possible, now you are going to read it from the it has returned the file pointer. This file pointer, it is going to point to the standard output. It is going to point to the standard output because you have opened in the read mode, and if you have opened in the write mode, this f pin, that is why the file pointer to the standard input, that is the meaning of fp in. It is not fpin, file pointer to the standard input, or else this will be fp out if you have opened in the write mode. Now this pointer, it is pointing to this file. This, the standard input, whatever we write, the standard output, that is always be line buffered, which is the line buffered means one by one line it is going to send the data. Line by line it is going to data. Even though it contains plenty of data, the standard output, it will be line buffered. If you want one line, it is going to send the output. After that, if you want to send it once again, then you have to f flush standard output, then only it will send the remaining data, or else it will send line by line. Yes, you remember that much, and we'll discuss in details about this filter, what this my uppercase to lowercase it is doing in this program, and what you have to understand from this, how it will be useful for the next topic for the co-processors, that we'll discuss in the next class. And all the best for your third test. If you have sent the attendance, you can exit.